Okay, so we're going to try this right here. We're going to classify triangles and quadrilaterals. So first, we're going to have a triangle here, and we're going to name the vertices A, B, and C. So remember, vertex means where two lines meet. Okay, so this triangle consists of vertices, sides, and angles. So we have the vertices are A, B, and C, and then you can name the sides. Those are line segments. So we have line segment AB, line segment BC, and line segment AC, and they are denoted by a straight line on top without any arrows. And a triangle, so tri means three, so they have three sides and also three angles. So we can name them as angle A, angle B, and angle C. We could also have named them with three letters as well, such as angle BAC, or angle ABC, or angle BCA. Those are also correct. And then ways to name a triangle. There are also many different ways, but you use just a triangle symbol, just triangle, and then you just say ABC, or triangle BCA, or triangle CAB, and all of those backwards as well. So triangle CBA, triangle ACB, and then triangle BAC. So you're just following the vertices around. So those are the names of this specific triangle here. Okay, now a lot of you guys remember we just did angles. So now we have triangle names. So actually a lot of people forget that you can name triangles by the angle and the side. So every triangle can be named two different ways, or classified two different ways. So first you have this, and this is by the angles. So look at all three of those angles there, and if all three of them are acute or less than 90 degrees, then that's an acute triangle. So all angles are less than 90 degrees here. And remember, you have to have this square there, either that or it's showing that it's actually 90 degrees, because you cannot assume that that's a 90 degree angle. It could be 89.9 or 90.2 degrees and it'll look like a right angle. But since that's there, this is a right angle. Okay, so since that's there, this is a right angle. So it's a right triangle. So only one angle is equal to 90 degrees, which makes sense because if you had more than one angle equal to 90 degrees, that would be impossible for you to have a triangle. If you think about it, this is 90 degrees. If you put another 90 degree angle there, that there's no way this is going to meet this line over here. So it has to be just only one angle equal to 90 degrees. Kind of the same way as the next one. So the next way we classify a triangle by its angle name is going to be with this. Whoops. Now here, you can see you have two angles here that are acute angles, but that doesn't matter because this one right here, that is going to be greater than 90 degrees. So in this case, you remember that an angle greater than 90 degrees is called an obtuse angle. Now this is a triangle with one angle greater than 90 degrees, and now it's an obtuse triangle. So those are the three ways to name a triangle by its angle. And you can also, there's other exceptions, but we'll do that after naming them by the side. So side, here we go, there's that, and these lines, those red lines right there, mean that each of those sides are equal to each other. And when all three are equal to each other, that's called an equilateral triangle. So all three sides are equal. So here, only two are going to be equal to each other. And in that case, it is an isosceles triangle. And more specifically though, because some students get mixed up with this, an isosceles is at least two sides are equal. So every equilateral triangle is also an isosceles triangle because it has at least two sides that are equal. And then here's a more common than one that you'll see. If no sides are equal to anything, to each other, then that is a scalene triangle. Interestingly enough, there is, if you have an equilateral triangle, that means that all the angles are also the same. So that's something else called an equiangular triangle. That means all three angles are the same. But of course, to confuse you more, an equiangular triangle is also an acute triangle because all of them are going to be 60 degrees and all angles are 60 degrees. 60 degrees is less than 90, so that would mean all equilateral triangles are also acute. Okay, let's move on to angle-side relationships. So sides opposite congruent angles are congruent. So what does that mean? So let's check out this. This looks like it would be an equiangular triangle, which also means an equilateral triangle, but we'll prove that. So here, sides opposite congruent angles are congruent. So let's say this is 60 degrees, then that would be some side length. If this is also 60 degrees, it would be the same exact side length as the one on the bottom. Same goes for this. If this is 60 degrees, this is also going to be the same side length. So for example, here, this is an isosceles triangle, right? So that means if you're looking at this angle and this angle, you're gonna look to see where this is pointing. This is an angle here, it's pointing to this side, that's a certain length. This is pointing to this side, that's the same exact length. So if we knew that this left side of the triangle was 5 inches, that means this right side would also be 5 inches. Okay. So, and then the converse is also the same. Angles opposite congruent sides are congruent. So looking at this, if all of these sides are the same, they're all 10, that means it's an equilateral triangle. That means this would be a certain degree. You don't exactly know yet. But then if this is 10, that means this over here is also going to be the same degrees, and this would also be the same. Okay, so those would all be the same angle measure. Same as this one. There's no little lines there, but since this is 7 and this is 7, that means they're the same. So this is pointing to this angle here. That's a certain angle. I don't know what angle that is, maybe 20 degrees. And then 7 is pointing here. That's also would be 20 degrees. Right now, why don't we name each triangle below? And by name, I mean using a side name and an angle name. So I'm going to go ahead and pause this and let you have time to answer it. Okay, so I'm assuming you paused it, or if this is on Edpuzzle, then you went ahead and did that. So here, this first one, we have two sides here that are equal, and the third is not. So that would be an obtuse angle, and it would be isosceles because of the 6 and the 6 are the same. Okay, for number 2, we had these markings here, and all 3 of them were the same. That means acute, or you can also say equiangular, and it's equilateral because all 3 sides are the same. For number 3, we have this symbol here, which means it's a right angle, and 3, 4, and 5, those are 3 different side lengths, so that would be scalene. And this last one here, that would look like an obtuse angle. It definitely looks beyond 90 degrees, and 3, 7, and 9 are all different sides, so that would also be scalene. All right, let's try more. So I'm gonna give you time to answer this. Okay, so this one, 2, 4, and 7 looks acute to me, and all 3 sides are different, so it's scalene. Number 6, acute, and since these are the same angle, that means these sides opposite them are going to be congruent. So that means it's an isosceles triangle because there's only 2 of them. Number 7, we have this symbol here, so it's going to be a right angle if you're naming it by its angle, and 3, 5, and 7 are different sides, so it's going to be scalene. Okay, and then so number 8 with side lengths of 5, this is the same as this, and there's only 2 of them because it didn't say anything about this one right here. So it's going to be not obtuse. That's wrong. This is going to be right. And there are the same size here, so isosceles. All right, good. Moving on, 180-degree rule. So there are a lot of other videos that actually prove this, and maybe I'll put one out in a little bit. But in this case, we're just going to talk about it, and then maybe I'll do a proof in a little bit. So every triangle has angles whose sum equals 180 degrees. So here I have just any old triangle, and I named the angles A, B, and C. So what the 180-degree rule means that if you add up the angle measures of all 3 sides of the triangle, they will equal 180 degrees. Okay, so if I were to solve for x here, so this is why we did solving equations a couple of chapters ago, because you'll need to use that knowledge for this. If I wanted to solve for x, I would have to know that all 3 of these angles would equal 180 degrees. And if I wrote this out, the measure of angle x plus 85 degrees plus 65 degrees equals 180 degrees. So I could kind of clean this up, and instead of saying the measure of angle x, I could just say x plus 85 plus 65 equals 180. So I'm going to combine my like terms here. 85 plus 65 is 150. And now I have just a nice one-step equation. 150 is being added to x, so I'm going to have to do the opposite of that, which is subtract 150 from both sides. And x is going to equal 30, or 30 degrees in this case. And then just make sure it kind of makes sense. This looks like an acute angle, and 30 degrees is definitely acute. If you did something wrong with your calculations or something and ended up with 130 degrees, looking at this angle, that does not look like 130 degrees. It does look like 30 degrees. Okay, so let's move on, and why don't you guys go ahead and try to find the missing angles here, and you can pause the video and try it out for yourselves, and then we'll do it together. Okay, so now that hopefully you've tried to find x, I know some of you guys can do this in your head, but it's a good practice to write out the equations to figure it out. So here we have the measure of angle x. This plus this angle will equal 180 degrees. So we're going to do the same thing. We're going to combine like terms first. X plus 135 equals 180, and we're going to solve for x by subtracting 135 to both sides. Then you get x equals 45 degrees, which does make sense. Here, the 18 degrees just kind of fit in there, so they're just putting an arrow for these angles here in the 24 degrees. But same thing, measure of angle y plus 18 degrees plus 24 degrees equals 180. Combine like terms to get 42. You subtract 42 degrees from both sides, so 180 minus 42, that'll equal 138 degrees. So I know maybe what you're thinking if you're doing this in your head, like, why do I need to write an equation if I could just take 180 minus, I could just do 180 minus 18 minus 24. And technically, yes, you definitely could do that, because you would still get 138 degrees there. But we're just practicing this because it's not always going to just be 18 degrees. It might be 2y, or it might be y minus 15. And in that case, it'll be much harder for you to do all of that in your head or using one step. So we're using the easy numbers first to kind of get you in the good habit of that, so you're not kind of caught up with the harder types of angle measures. Okay, let's move on. And okay, instead of moving on, we're going to stop there for classifying angles. So next up, we might be classifying quadrilaterals, but we'll see. In any case, that's about it for this lesson today, and I'll see you next time.